Okay, so for this lab, you need to go into Pivots Interactive, and I sent you the code to sign up for Pivots Interactive, and you're doing the Induced B field quantitative lab, trying to find the relationship between the induced magnetic field and the distance from the wire, R, and the current in the wire, I. So first of all, you need to understand that the magnetic field that we're going to be looking at here is actually a combination of two fields. The field from the Earth, I'll call that B naught, and the actual field that's induced because of the wire. And so really the angle that we'll measure from our compass is going to be a combination of those. So we're going to be plotting tangent of the angle versus R and tangent of the angle versus the current. So for this very first one, we're doing tangent the angle versus the distance. So I'm going to go ahead and hit play to find some kind of current. So it looks like about 0.49 there. Not sure, does it ever, nope, 0.49. And I can come up here with the tools and I can find out the distance away. And I'm going to say maybe the wire, maybe it's right here. I don't know if that's the position, or maybe it'd be better to use the shadow here. I'm not really sure. Let's go ahead and say it's this white dot here. And we're going to the center of the compass. So let's see, it's kind of hard to see the numbers. So here's 5. So every one of these is a half a centimeter. Each one of those little lines is a half centimeter. So it looks like it's, let's see, there's 1, 2, 3, looks like it may be about 3.5 centimeters away. So I can use this tool to measure out the distance away. And then right here is a compass. And so I can put the compass on here and I can figure out how much it rotated. So I think what I'm going to do is, let me go ahead and rewind this. And yeah, it's kind of straight there. So let me hit play, 0.49, pause it. And then here's a line that I can put this line on here, and I think I can rotate it around. Whoops. Maybe. Oh, there it is. I can rotate it around if it lets me. Oh. And let's see. Well, this is kind of hard to put on there. Kind of rotate it right along the compass needle. And it looks like for me, it's pointing at 345. So it went from 0 up to 345. So let's see, I guess that's 15 degrees. So it rotated 15 degrees. And I can get rid of that. And so that's at position 1. And then I can change this to position 2, hit load. I can hit play, and right there is 0.49 again. And I can measure this distance. And so I can find out what that distance is. So it's 1, 2, 3, 4, 5, 6, about 6 centimeters away, I guess. And I can measure the angle. Let's see here. And here's my align tool. It's right in the center here. Now I can rotate it. Whoa, what happened to my line? It moved on me. Sorry about that. But anyway, you can put that on here. Measure it so I can see how many degrees it is. And record that. And I can get lots of different distances. So let me change it. I'll go all the way up to 5, hit load. And so let me get rid of this, hit the measuring tool. And so I can put this on here, measure how far all the way out to the center, is. I can hit play. And there's 0.49. Put my compass protractor on here. Is it not going to load? Hold on. Ah, there we go. This one's going to be kind of hard, isn't it? Put the line on here. So I can rotate this to here. Now, obviously, I can't read out this way, but I can read this far, and I can see how far it is on 180, and that will give me the same angle there. So I can find that angle as well. So that works out really well. Okay, so that's the first part of the lab. Now, keep in mind you're plotting tangent of the angle versus r. Okay, for the second part of the lab, you're going to be plotting tangent of the angle versus the current. So let me go ahead and move this back to position 1 because I think it's going to be more noticeable. So I can hit play here. And so there's 0.49, and I can measure the angle, and I can measure what the distance is away. And so I know what that constant distance is. That won't change. And then I can hit play and get a different current. So there's 1. Okay, and I can measure that angle. The distance away did not change. And then I can hit play again. Oops, I might want to do 0.99. Okay, now there's 1.5, and I can find and measure that angle. And there's 2, I can measure that angle. There's 2.5, I can measure that angle. There's 3, I can measure that angle. There's 3.51, 3.5, I can measure that angle. There's 4, I can measure that angle. I'm not sure if that's 6 data points or not. It looks like we have one more, 4.51, I can measure that angle. And so what you're doing for this last part, oh, it looks like you can even do 5 maybe. So measure that angle. So what you're doing for this last part is you're plotting tangent of the angle versus I and figuring out what the relationship is, okay? After you find those two relationships, you should be able to combine those relationships into one mathematical model. We've done this plenty of times. We did it last year, we did it this year, lots and lots of times to get one composite model. And then we know that tangent of theta is equal to the induced field, B theta, divided by B naught, where B naught is caused by the Earth. And the Earth's magnetic field, I'm just going to go ahead and give it to you. It's measured in what we call Tesla. That's what the T stands for. So 2.01 times 10 to the negative 5th Tesla. And so you can go ahead and find the exact mathematical model, okay? And that's what you're doing.